Hi everyone, welcome back. In this video, we will keep doing 2016 Gauss contest grade 7, part C, the first three questions, 21, 22, and 23. Question 21. A 10 by 10 grid is created using 100 points as shown. Point P is given. One of the other 99 points is randomly chosen to be Q. What is the probability that the line segment PQ is vertical or horizontal? So if we take a look, we want this line to be either horizontal or vertical, so all the points must lie on these two lines. So we can simply count all the possible points. We have all these possible points that could be chosen such that if we connect the red dot with with P, it will be either horizontal or vertical. And the total number of these points would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we would have 18 points out of the 99 points that we can choose. And if we simplify this fraction by dividing 9 on both top and bottom, we would have 2 over 11. Easy like that. Question 22 would be a bit more complicated. The 8 vertices of a cube are randomly labeled with the integers from 1 to 8 inclusive. Judith looks at the labels of the 4 vertices of one of the faces of the cube. She lists these 4 labels in increasing order. After doing all these for 6 faces, she gets the following 6 lists, 1, 2, 5, 8, and such, so on and so forth. The label of the vertex of the cube that is farthest away from the vertex labeled 2 is. So let's start doing this question by drawing a simple cube here. And then we want to try to label some of the points. The thing that we want to recognize is that such as we have 1, 8 in this list, and we also have 1, 8 in this list. That means 1, 8 is definitely on one of the edges. So let's start by labeling this as 1, this vertex is 1, and this vertex is 8. Because 1, 8 is 1, 8, this edge is shared between 2 sides. That's why these 2 numbers appear in 2 lists. There are also other occasions like this, such as we have 3, 6 in this list and 3, 6 in the other list. So there's no one correct way to start this question. I just choose edge 1, 8. And then we can go on and look at the first list here, 1, 2, 5, 8. So 2, 5 must occupy this edge right here. However, we're not sure if 5 is here or 5 is down there. So we can just leave it like that. So we know that 2, 5 definitely occupies that edge. Then 1, 3, 6, 8. So we know that 6 and 3 occupies this edge. However, we're not entirely sure what's the order of those 2 points. And we can see that we can go on and look at maybe this list right here, 2, 4, 5, 7. So we have 2, 5 here. So we must have 4, 7 on this edge, because they can makes up one side. And if we look at this, 3, 4, 6, 7. So 3, 4, 6, 7 is definitely the back side over there, because they have 3, 4, 6, 7. But same thing happened again. We are not entirely sure what's the order. And then 2, 3, 7, 8. 2, 3, 7, 8 would be the first breaking point that we have. So 2, 3, 7, 8 must be on the side that 8 is on. It cannot be this side because it is 1, 8 something. It cannot be the front side because the front side is 1, 8, 2, 5. So it must be the bottom side. So if we want the bottom side to have all these numbers 2, 3, 7, 8, we will start by labeling this point. This point must have 2 because this vertex only have 2 possibilities, either 2 or 5, and we want 2 to be here. This vertex, we want the 7 to be here because this vertex as well only has two possibilities, 4 or 7. And we want the number 7 to be on the bottom face. So it needs to be 7. Same logic here. This needs to be 3 because even though this vertex has two possibilities, 3 and 6, we want the 3 to be on the bottom face, such as the bottom face will be 2, 3, 7, 8. So if we distributed this 2 on the bottom, the top vertex right here must be 5. This top vertex right here must be 4, and this vertex here must be 6. So now if we look at this vertex 2, because we are looking for the furthest away vertex from 2, which would be actually, if we connect these two vertex, they would be the furthest parting way in this cube, which means the answer would be 6, option D. Question 23. Angie has a jar that contains 2 red marbles, 2 blue marbles, and no other marbles. She randomly draws 2 marbles from the jar. If the marbles are the same color, she discards one and puts the other back into the jar. If the marbles are different colors, she discards the red marbles and puts the blue marble back into the jar. She repeats this process a total of 3 times. What is the probability that the remaining marbles red? So we know that we have 2 red marbles and 2 blue marbles in the beginning. So let's make some hypotheses. So let's say in the first round, we have a few different possibilities. The first possibility is that we actually draw 2 blue. Second possibility is that we draw 2 red. And third one is we draw 1 red, 1 blue. So we look at these possibilities respectively. For the first possibility, if we draw 2 blue in the first round, they would all be discarded. We would discard one of them because which means that 1 blue would be automatically discarded. So we would be left with 2 red, and 1 blue. And in the next round, we still have 2 possibilities. The first possibility is that we draw 2 red automatically, and we would discard one of the red, and we would have 1 red and 1 blue. 1 blue left. And for the third round, we only have one choice to draw these 2 balls, which is marbles, which is to draw 1 red and 1 blue. And then we would discard the red, which means at the end of third round, we would only have 1 blue left. And the second possibility stemming from this one is that we draw 1 red, 1 blue, and same thing happened. This red one will be discarded, and we would only have 1 red, 1 blue left. And after that, it's going to be a single blue. So the first possibility, if we draw 2 blue in the first round, give us no probability of getting any red left. For the second one, if we draw 2 red in the first round, we would discard one of the red, so we would leave with 1 red and 2 blue. And for the next round, we would still have 2 possibilities. The first possibility is that we draw 1 red, 1 blue, such that we discard one of the red, so we would leave with 2 blue. So no red is left. The second possibility is that we draw 2 blue, and we would discard one of the blue and draw and have 1 red, 1 blue. And then after that, we would only have one choice to draw the 2 marbles left. And we would discard the red one and left with the blue one. So which means the 2 possibilities stemming from the second scenarios, draw 2 red in the first round, also give us no red balls left. And the final possibilities, draw 1 red, 1 blue in the first round. So we would need to discard the red one and put back the blue one. So we would have a blue one. We would have a red one and 2 blue one left. And since this is exactly the same as this scenarios right here, so we would conclude that this also have zero possibility that we would have a red marble left at the end, which means all the 3 different possible scenarios that we would have for our first round marble selection, none of them work, which means we have a 0% of possibility that the remaining marble is red. And that would be the correct answer for question 23. And thank you very much for watching.